Okay, so we're going to prove that the area of a triangle is 1/2 base times height. So what we're going to first do is try and understand what this is saying. It basically just says that the area of this triangle, everything on the inside, everything here, is equal to this length times this length. And that's the base, this length down here that I'm highlighting, that's the base. And then this over here is a height. And a height has to form a 90-degree angle right here. And the area, everything on the inside, is again equal to this length times this length divided by 2. And that's exactly what this says right here. Now we're going to prove this statement. So what we're going to do is we're going to first look at this triangle. So this is any triangle. And what I'm going to do is I'm going to sort of draw this rectangle. So how do I draw this rectangle? This is a 90-degree angle right here. All right, so let's change this. So this is a 90-degree angle right here, okay, that the height makes with the base. So then that means that this is a right triangle. And I'm going to duplicate this right triangle and I'm going to turn it over and paste it back like this. And we should see the 90-degree angle comes to over here. If this is angle X and then this is angle Y, let's say that this is angle X and then over here is angle Y. Let's change our color again. Let's see if we get a better one. If this is X and then this is Y, we should convince ourselves that then this is Y and that then this is X when I flip this triangle around back onto itself over here. And what we should convince ourselves is that X plus Y is 90 degrees. Okay, this is a 90-degree angle right here. And the sum is 180, so that means that X plus Y has to be 90. So that means that this whole thing is a 90-degree angle, and this is a 90-degree angle because it's X plus Y again. Similarly, and for similar reasons, I can take this triangle on the left, duplicate it, glue it back so it's over here again, and I'd get something that looks like this. And again, this would be a 90-degree angle. This would be a 90-degree angle for the same reason that we were just discussing about this X and Y stuff with the other triangle. And what we would have actually here is that this is a straight line, and this is a straight line, of course, the original straight line, and this new figure is now a rectangle. If you look at this new figure, we should convince ourselves that the area of this new figure is twice the area of the original triangle. Why is that? Let's just start coloring these figures in different colors. Let's call this the green triangle over here. And I'll call, I don't know, this one over here the pink triangle. And we should start writing equations. We should say, what do you want to call this? Let's box this one in. Let's call this a different color. Let's say it's red. So let's say this is the red rectangle, right? So let's write the, not quite, let's make it different. Let's say that this is the blue rectangle. So now let's write an equation. Let's say that the area of red rectangle plus the area of blue equals area of, let's say, the big rectangle. Of blue rectangle is the area of the big rectangle. Now that should be clear, right? The area of, I'm going to erase this in 2 seconds, the area of this rectangle plus the area of the blue, this rectangle, you should see is the area of the entire rectangle. So like this is the entire rectangle here, right? Now let's come up with a relationship for other things in this figure here. Now, what is the area of the red rectangle? Well, isn't the area of the red rectangle twice the area of the purple triangle? So we have one equation right here. So So let's keep this in our minds. This is 1, let's say, one equation. 2, the second equation, is I'm going to say that the area, or 2 times the area, and I want to distinguish from that 2, so I'm going to move it over a little bit. 2 times the area of purple triangle is equal to the area of the red rectangle. And we also have, for similar reasons, that, you know, if I say 3, I don't know if it's necessary, but 2 times the area of the green rectangle, of the green triangle, is equal to the area of blue rectangle. And again, these 3 statements should all fairly be obvious. Let's just convince ourselves of all 3 of these again. Well, the area of the red plus the area of the blue is clearly the area of the whole thing, right? The area of this plus the area of this is the area of the entire rectangle. That's obvious. Now, why is it that 2 times the area of the purple triangle is the area of the red rectangle? Well, the red rectangle was made by doubling this triangle. So I doubled this now blue triangle. I doubled it, the original purple one, and I flipped it over and I pasted it along this line to make this red rectangle. So of course, since it's 2 of those purple triangles, the area is double. 2 times the area of the purple triangle is the area of the red rectangle. 2 times the area of the green triangle is the area of the blue rectangle, and that's for the same reasons. Now, what this means is that if we put this together, what we should see is that, well, let's write another equation. Now I have these 2 equations here. I'm going to plug 2 and 3 into 1. So instead of writing the area of the red rectangle, I'm going to write 2 times the area of purple triangle plus 2 times the area of the green triangle is equal to the area of the entire rectangle, or area of big rectangle. And we're going to draw that for a rectangle. Okay, now this statement here is, again, something that should be relatively obvious, right? All I did was I just substituted in. After this, now let's say something about, let's see, what do we want to say? Now I'm just going to do some algebra. So this here has a 2, this here has a 2. Let's see what I can get. What I get is that I can factor out that 2. So I get area of purple plus area of green is equal to the area of big rectangle. And now I have like pretty much a few minor steps to say, or a few minor reasonings. So the next thing is now let's look at this equation on the inside here. So I just factored out that 2, and I got this equation on the inside. You could see that these 2, you should see how this is the same. Going back, you could distribute the 2 back and get back the other one, get back that one when you distribute 2. But okay, now this inner one that I've highlighted in yellow, we should convince ourselves that this is the area of our original triangle. This area, right, this purple area, this purple triangle, area of the purple triangle, plus the area of the green triangle is the area of the entire triangle, this triangle right here. So I'm just going to write this as 2 times, and instead of me writing this sum, I'm going to write it as 2 times the area of, and I'm just going to say triangle. And it's equal to the area of the big square. Now let's investigate the area of the big square a little bit further. So let's look at this, the area of the big square. Well, what is this? Well, this length for sure for the big square is definitely b. And if we remember, this length is a height going down. And that height will exactly line up to this height over here, or this length. And the area of the rectangle is just going to be this length times this length. In this case, it's b times h. So the area of this entire rectangle is b times h. And I'm going to write that instead, b times h. And now I pretty much just have one last step, because you see over here, this is just, this here gives me my equation, because I have 2 times the area of the triangle is equal to b times h. I divide by 2 and I get my result. I get that the area of the triangle is equal to 1/2, which is the same thing as division by 2, base times height. And I'm done.